Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss physical properties and chemical properties of ethers. Last class I have discussed preparation of ethers. Now I am going to discuss physical properties and chemical properties of ethers. The CO bond in ethers are polar and thus ethers have a net dipole moment. The weak polarity of ethers do not appreciably affect their boiling points, which are comparable to those of the alkanes of comparable molecular masses, but are much lower than the boiling points of alcohols. This is the, you can say, physical properties. And example I am telling you about the boiling points, that normal pentane, its boiling point is 309.1 Kelvin, and ethoxyethane, its boiling point is 307.6, and butane 1-all, its boiling point is 390. Then here what is the important point? The weak polarity of ethers do not appreciably affect their boiling points, which are comparable to those of the alkanes of the comparable molecular masses. Means molecular masses are if roughly same, in that is called comparable to those of alkanes of comparable molecular masses, but are much lower than the boiling points of alcohols. Okay, but boiling points are very low. Then example I have told you, normal pentane, ethoxypentane, butane 1-all. If you compare all three, then normal pentane means CH3, CH2 whole 3, CH3. This is actually alkane. Its boiling point is 309.1. And ethoxyethane means C2H5O, C2H5. Its boiling point is 307.6. And butane 1-all, alcohol. Butane 1-all means alcohol. Its boiling point is more, 390. Then why is so difference? I am telling you, the large difference in boiling points of alcohols and ether is due to the presence of hydrogen bonding in alcohol. And in alcohol, hydrogen bonding is there, but ether, no hydrogen bonding. The large difference in boiling points of alcohols and ether is due to the presence of hydrogen bonding in alcohols. The miscibility of ethers with water resembles those of alcohols of the same molecular mass. Both ethoxyethane and butane 1-all are miscible to almost to same extent, that is the 7.5 and 9 gram per 100 mole. Okay. This is, I am talking about miscibility. The miscibility of ethers with water resembles those of alcohols of the same molecular mass. Miscibility of ethers and water resembles means it is almost same those of alcohols of the same molecular mass. Both ethoxy ethane and butane one all, their molecular mass is almost same, are miscible to almost the same extent, that is the 7.5 and 9 gram per 100 ml. It is a miscibility in water I have talked you. While pentane is essentially immiscible with water. Pentane is alkane. It can't make a hydrogen bond with water. Then pentane is essentially immiscible with water. This is due to the fact that just like alcohol, oxygen of ether can also form hydrogen bonds with water molecules. You know, these two molecules, if you are considering ether, suppose ROR is ether, and other, now you consider alcohol, ROH. Then now this ether and alcohol also can make bond, because O is electronegative, and this things HOH, I am talking about water. Why this ether is miscible with water, that I am telling you. ROR, that is the ether, and water is HOH. Correct? Two molecules of water you can consider HOH and again HOH. Then H of water and O of ether, they will just attract to each other. Means both will make hydrogen bond. Okay. Other molecules also, water is there, suppose, then that H of water and O for ether, they will attract to each other, because oxygen is electronegative, hydrogen is electropositive. Then they will make bond. That's why miscibility takes place. That is alcohol, you can say, is miscible with water, and this ether is miscible with water. Now I am discussing about chemical reaction. Chemical reaction means chemical properties. Then here first I will discuss cleavage of CO bond in ether. In ether there is a bond between carbon and oxygen. Alkyl group like ethyl or methyl, carbon is there. Then oxygen makes bond with carbon, that is called CO bond. Then now chemical reaction due to cleavage of CO bond in ethers. Then on the basis of this cleavage of CO bond in ethers, reaction I am telling you. Ethers are the least reactive of the functional groups. The cleavage of CO bond in ether takes place under drastic condition with excess of hydrogen halide. The reaction of dialkyl ether gives two alkyl halide molecules. Reaction you can understand. ROR, this is the ether plus HX. What it will give? Easily you can understand that R and O bond will break. Then O will take electrons and it will become negatively charged, and R will be positively charged. Correct? And H will have positive charge, X will have negative charge. Then very simple way that ions will go to the oppositely charged, means H plus will go to the O minus, H plus will go to the O minus, and it will form ROH, means alcohol. When R and O bond breaks, means carbon and oxygen bond breaks, then it forms alcohol. Plus X is negatively charged, then it will go to the R plus and it will form RX, halide, alkyl halide. Other example, if you will take of alcohol in the alcohol, what will happen? Then same thing will happen, ROH plus HX. Then again that R and O bond will break, then R will have positive, O will have negative. Then HX bond, where the H and X bond, when it will break, X will get negative. Then negative will go to the positive, R. Then it will form RX. And ROH, then O was having negative charge because it is electronegative element, atom. Then O negative, that will join with H plus, means it will form water. Very simple reaction. Alkyl aryl ethers means oxygen has two valence, one side benzene ring, other side alkyl. That is called alkyl aryl ethers. Alkyl aryl ethers are cleaved at the alkyl oxygen bond due to the more stable aryl oxygen bond. Now here you have to understand that this O is attached with R also and O also. O is attached with R also and benzene group also. Then which bond will break? Bond between O and R will break, or bond between O and benzene will break. That you have to understand. Okay. Then alkyl aryl halides are cleaved at the alkyl oxygen bond. Why? Why not oxygen and benzene ring? That bond also should break. Then now I am telling you, this happens, alkyl oxygen bond breaks due to the more stable aryl oxygen bond. Aryl oxygen bond is stronger than OR bond. That's why OR bond breaks. The reaction yields phenol and alkyl halide. Reaction will be same way, only you have to understand that which bond is stronger. Then OR bond is weaker than O and benzene ring bond. Between O and benzene ring, that is stronger. Why it is stronger? Then you know that in benzene ring double bond is there, alternate double bond. Then carbon is sp2 hybridized. sp2 hybridized, correct? And due to that what will happen, that this benzene rings requires electron, then that will be given by oxygen, okay? And that's why OR bond will break, because when this bond will break, OR bond, then oxygen will take electron and R will be free as R plus, and that electron will be taken by, actually this benzene ring itself is stable due to alternate double and single bond, but it is sp2 hybridized. sp2 hybridized, correct? It will take the electron. Then now this bond will break only from O and R. O is negatively charged and R is positively charged. Hence HX, when this alkyl aryl ester react with HX, then same way reaction. HX will break and H will positive, X will be negative. Then both will go to the oppositely charged. Means H plus will go to the O. Then it will form OH. Then now you will get phenol. It will give phenol because with benzene only O was there, phenoxide. Then now H will join there. Then it will form phenol. And R is positively charged. It will go to the X which is negatively charged. It will form RX. Ethers with two different alkyl groups. Ethers, suppose in ether two alkyl groups are different, then what will happen? Ethers with two different alkyl groups, suppose one side R is there, other side R dash is there. One side may be methyl, other side ethyl. Both are different. Suppose if both are different, then what will happen? Ethers with two different alkyl groups are also cleaved in the same manner. Then it will form RX plus R dash OH. Correct? When R and O bond will break, R will be positively, O will be negatively. The same way it will form R plus and X minus. RX it will form, and other RO was there, O is negatively, and H will join with oxygen. It will form alcohol. Alcohol, correct? R dash OH, and other product is RX. The order of reactivity of hydrogen halides. That question is asked, the order of reactivity of halogen halides. Then it is as follow. Hi is greater than HBr. HBr is greater than HCl. Here iodine is, size of iodine is more. You remember. Then Hi, order of reactivity of hydrogen halide. Then Hi is greater than HBr. HBr is greater than HCl. The cleavage of ethers takes place with concentrated Hi or HBr at high temperature. Bond will break. The cleavage of ethers takes place with concentrated Hi or HBr at high temperature. High temperature is required. Okay. Now if you want to understand the mechanism is very easy for this reaction. Suppose methyl, and already I discussed, one side is methyl group is there, other side suppose ethyl group is there. Then in step 1, what will happen? That suppose reaction is going with Hi, then where you know that bond breaks only when that atoms are means that if someone is ready to give the electron, only that time bond will break. Bond breaks only when atom will have hope for electrons from the other atom. Only then it will break. Then now CH3O, CH2, CH3 means ethyl, methyl, ether. One side methyl group, other side ethyl group, and in the middle oxygen is there. Oxygen has 2 lone pair of electron. Then what will happen? Then out of 2 lone pair of electron of oxygen, 1 electron pair will be given to, it is ready to give it one pair of electron to H of Hi, H of Hi. Then H will come, H will break the bond with I, and it will come to O. Then now I became free as I minus, and H came there near the O as H plus. Then one pair of electron will be donated to H. Then now oxygen will become positive because one pair electron is given to H. It became oxygen became positive, correct? And I will leave, will break the bond and will take the electron plus I. Okay, plus I minus means I will get iodide ion because Hi bond broken. The reaction takes place with HBr or Hi because these reagents are sufficiently acidic. One more reason is that these HBr, why reaction takes place with HBr Hi, then reaction takes place with HBr Hi because these reagents are sufficiently acidic. Acidic means it can release the H plus easily. Now after that, second step, what will happen? Iodide ion, I told you, it became free, iodide ion. Then iodide is a second step, I am telling you. Iodide is a good nucleophile, means I minus. It attacks the least substituted carbon of the oxonium ion formed in step 1. This iodide will, where it will go? Because iodide is a good nucleophile. It attacks the least substituted carbon of the oxonium ion formed in step 1 and displaces an alcohol molecules by SN2 mechanism. SN2 means this second order, and a step will be 1. Only in one step reaction will take place. Okay. Only in only in one step reaction will take place. But it is a second order, means it will depend, reaction will depend, rate of reaction will depend upon two concentration. Okay. Concentration of two reactions. Then one is the I, and other will be here, means here means ether and Hi, both concentration. This reaction depends upon concentration of both. Then now here what will happen? Iodide ion will come to the, you can say, oxonium, to the oxonium ion, and there I minus will come to the carbon of oxonium. That carbon will have hydrogen. Then that carbon actually methyl group CH3 is attached with oxygen. Then that carbon requires actually oxygen. That carbon requires actually electron, that will be given by iodide ion because it is negatively charged. Then now what will happen? That I will try to make the bond with CH3 of oxonium ion formed in step 1. Then now as soon as I will make bond with CH3, then bond between CH3 and O will break. I told you, when someone is ready to give the electron, only that time bond will break. Simply it will not break. And that is actually a role of sometimes I can say catalyst. Catalyst for short period, they will give electron. Okay. And high temperature also, high temperature, pressure, that time it will help to break the bond. In general, I am talking about. Then now I raise to the CH3 of oxonium ion form in step 1, and it will form CH3I, and as soon as I will attach to the CH3, bond between CH3 and O will break, correct, and it will form CH3I. Then now what will happen, that I will take the electron. I will take the this oxygen will take the electron when CH3 and O bond will break, because it is electron negative. Then now what will happen, this bond will break, CH3 and O bond will break. It will form, because CH3 will become positive charge, because oxygen will take its electron. Then CH3 plus, C will become CH3, carbon of CH3 will be plus. Then that time iodine, which is a negatively charged, will give the electron to methyl group carbon, that is positively charged, and it will form CH3I. And now what will happen, that this remaining portion of the oxonium, they will form ethyl alcohol, CH3, CH2. OH bond was there, but that time O was having positive charge. Now it got one pair of electron. That's why positive charge will neutralize. Oxygen got back their electron. What it was donated to hydrogen, now methyl group, that bond when broken, that electron oxygen got, and that positive charge neutralized, and you will get ethyl alcohol, CH3 CH2 OH. This is the actually in the intermediate for a short period, that is the when I is approaching to CH3 ... you can write. Okay, this is, I told you, SN2 means one step reaction. Then I will make as an intermediate, you can write transition state, you can write, not intermediate, transition state for short period. Then I will make a ... bond, and that this bond O and ethyl bond CH3 CH2, that bond actually that will also become weak. As soon as I will approach to CH3 and O bond become weak, and this side also bond will become weak, ethyl side CH2 CH3 also become weak, both side bond will be weak. And as soon as I will actually this condition what I am telling you, this is for transition period, for very short period, and after that quickly what will happen, this CH3 and O bond will break. That time now it will become ethyl alcohol and oxygen bond will become strong. It will become strong. Now it will not break. When I was approaching and CH3 was breaking, that time it was also becoming weak, ethyl and oxygen bond. But as soon as this bond will break, CH3 and O bond, then this bond will become a stability, and it will form CH3 CH2 was there, OH bond will form. OH will attach to the CH2. It will make a strong bond. Means you will get methyl iodide and ethyl iodide. When HI is in excess, when hydrogen iodide is in excess, and the reaction is carried out at high temperature, ethanol, what it formed, ethanol reacts with another molecule of HI and is converted to ethyl iodide. Okay. Then now if HI is more, then in that situation, and if temperature is high, at high temperature, and when HI is in excess, then this ethyl alcohol which you got can react further with another HI. in the same way. In the same way, and it will form, H will go to the O, and I will be separated, and that I in second step will come to the CH2, CH3, CH2, OH was there, then near the O, H came, then that O became positive because it has given electron to H. Then now iodide will come to the CH2 of ethyl group, and there it will make a bond. Then in that situation, what will happen? As soon as I will approach to the CH2, and it will give electron to CH2, then it will make a bond CH2I. Then you will get the product CH3CH2I, ethyl iodide, and this OH with two OH, that will become OH2, means H2O, because H came to the oxygen. H of HI came to the oxygen, correct? Because it was ethyl alcohol. OH is there, near that O, one can say H of I came, then now it became OH2. Then as soon as I bond will formed, this bond will break. CH2 and OH bond, which was the bond between CH2 and OH, that bond will break, because one H plus is there, and it will go as H2O, water. Means if second molecule of HI is there, then it will form ethyl iodide plus H2O. Ethyl iodide plus H2O. Okay. Then this I have discussed this thing's mechanism. However, when one of the alkyl group is a tertiary, then what will happen? This is an important question. When one of the alkyl group, both side alkyl group is there, R and R dash. Now suppose when one of the alkyl group is tertiary group, the halide formed is tertiary halide. Obviously it will form tertiary halide, and reaction will be as it is. Means this one side oxygen is 2 valence, one side methyl group, other side tertiary alkyl group is there. Means oxygen is attached to the carbon, and that carbon is attached to the 3 alkyl group. Then bond will break. You know that H will come to the O, HI, that H will come to the O, it will form CH3OH, and I will attach to the carbon, alkyl, tertiary alkyl carbon, there it will attach. Okay, then you will get alkyl, this alcohol plus tertiary halide you will get. CH3, 3 CH3 group is attached with carbon, that carbon is attached with I. It is because in step 2, why does it happen? So you know, it is because in step 2 of the reaction, the departure of leaving group means OH and CH3, methyl alcohol it is forming, then there OH and CH3 bond is there, then this OH and CH3 creates a more stable carbocation. If it will go, then more stable carbocation means C, with this C3 methyl group is attached, that carbon will be C plus, because oxygen has taken its electron during breaking of the bond, and the reaction follows SN1 reaction. Means this reaction will take place in 2 steps. SN1 means reaction, first order reaction in 2 steps. Then here carbocation will be formed. which is the carbocation? Then here carbocation is C have positive charge and 3 alkyl group is there. Then this is the carbocation. Then intermediate is formed as a carbocation, and that carbocation will react with iodide ion and it will form Ci bond, C plus and I, Ci bond, and that carbon is attached with 3 alkyl group. Okay. Then here these things, in case of any sol, suppose now any sol is there. In case of any sol, methyl phenyl oxonium, methyl and phenyl, both group will be there in any sol. That's why it is called methyl phenyl oxonium ion. Then means C6H5, that is attached with CH3 group. C6H5, this phenyl group is attached with O and O is attached with CH3. Then in case of any sol, that H plus will come near the oxygen and same thing will happen. Oxygen will donate one pair of electron, oxygen will be positive charge. Then in case of any sol, methyl phenyl oxonium ion, that one positively charged oxonium ion, you can say oxygen will have positive charge, that is formed by protonation of ether. Okay, suppose ether, suppose you are talking, then one side phenyl group, other side methyl group is there, and if hydrogen will come near the O, then what will happen? This ion, oxonium ion, is formed. Oxonium ion is formed by protonation of ether. Means O will near the O, H will come, OH bond will form. This is called protonation, and O is having positive charge. The bond between, now you can see, the bond between OCH3 is weaker. This OCH3 bond, because oxygen is positive charge, the bond between OCH3 is weaker than bond between O6H5. Always remember, bond between O6H5 is stable, stronger than O and CH3. Okay, because phenyl ring, benzene ring is stable. Then this OCH3 bond becomes weaker than the bond between OC6H5 because of the carbon of phenyl group is sp2 hybridized, and there is a partial double bond character due to these two regions. Okay. Now I will discuss now electrophilic substitution reaction. Then, but here before going to electrophilic substitution, one point again in this reaction you can understand this, because this oxygen O and CH3 bond is weaker, and that bond will break. That bond only will break. Therefore, the attack by iodide ion breaks OCH3 bond to form CH3I. Methyl iodide will be formed, because when OCH3 bond will break, O will take the electron, CH3 will be positive charge, then I minus will come near the CH3I and it will form CH3I, means methyl iodide. Phenol do not react with this. After this, phenols do not react to give halide. Only if you will take phenol, suppose now reaction is phenol, then what will happen? Only phenol. Then phenol do not react further to give halide, because the sp2 hybridized carbon of phenols cannot go under nucleophilic substitution reaction needed for conversion to the halide. Okay, because phenol, because the sp2 hybridized carbon of phenol cannot go under nucleophilic substitution. Nuclear means negatively charged. There is no question of substitution. H is positive charge. Okay, and it is not. It will not go due to the sp2 hybridized carbons of phenyl cannot undergo nucleophilic substitution reaction needed for conversion to halide. Okay, then now I have this discussed this thing, reaction of ether with halide. Now I am going to discuss electrophilic substitution, E plus electrophilic substitution. Now I have discussed breaking of bond between C and O, correct? Or you can tell reaction with halide. That time only bond CO bond breaks. Now second reaction I am telling you, electrophilic substitution reaction. Then electrophilic substitution reaction means E plus. Then it will substitute only plus, like H plus, correct? That is called electrophilic substitution. Means E plus will just substitute or will take place with other ion which is positive, because both are positive and substitution can take place, same capacity. The alkoxide group means OR is orthopara directing and activate the aromatic ring towards electrophilic substitution in the same way as in phenol. Here this resonance structure already I have discussed. Suppose ether you are understanding that benzene, one side benzene is there, other side R is there, means with benzene ring OR is there, and O is having two lone pair of electron. Hence one pair of electron it can donate to make a double bond. O is attached to the benzene ring, then by single bond, but now it can give one pair of electron to make a double bond. Then that bond which was having double bond in benzene near that carbon, that will be shifted. That bond, double bond will become single bond, and electron will be taken by the next carbon. After that, you know what will happen. Next carbon will have negative charge, and O and C bond will become double bond, and O will have positive charge because one pair of electron is donated and single bond became double bond. But in the ring double bond was there with that carbon, that will break. To make stability, that carbon will break, and next carbon will have negative charge. Then this carbon again it can make double bond with next carbon, then next bond will break. You know all the things. It will form 4 resonance structure, and finally negative charge of carbon number 2 that will go to the carbon number 4 and then carbon number 6. Means negative charge is now delocalized, moved, circulated from carbon number 2 to carbon number 6. And when it will this negative charge means electron moved and it reached to the carbon number 6, then now that double bond and this charge means electron repulsion will take place, and that double bond which was made, that bond will break, and again oxygen will take that electron, and this negative charge at carbon number 6 will make double bond between 6 and 1, carbon number 1 and 6. Then like this way again O and benzene ring bond is single bond. Oxygen is having now again you can say lone pair of electron. correct, as usual. As usual, positive charge of oxygen now gone. Okay, then this fifth structure will be stable. Fifth structure, resonance structure, will be stable. Only difference became where it was single bond, in the ring where it was single bond, that became double, and which was the double, that became single. Complete rotation of electron. That's why it is stable. Then you have seen here ortho and para position, means carbon number 2, carbon number 4 have negative charge. Hence any group, you can say group which requires electron, means E plus can attack these two positions where it will gain electron, where there is a hope to take the just where electron is available, only that position it will attack, means it will join. Okay, means ortho and para position. This you should understand, that now any E plus like NO2, any positive charge, it will join either at ortho position or para position, means carbon number 2 and carbon number 4, correct. Now see halogenation. This is a general, I told you. Now halogenation, particular reaction you can see. Halogenation, phenyl alkyl ethers undergo usual halogenation in the benzene ring, that is anisole. When one side phenyl group is there, other side ethyl group is there, then that is called anisole. Okay, then phenyl alkyl ethers undergo usual halogenation in the benzene ring, that is the anisole undergo bromination with bromine in ethanoic acid. Even in the absence of iron third bromide catalyst, this reaction takes place. Generally this catalyst required, iron third bromide is required as a catalyst, but this reaction will take place without catalyst also, bromination. Then now anisole plus Br2, that when this Br2 in ethanoic acid, what will happen? Then bond will break Br2, one Br will get positive charge, other Br will get negative charge. Then Br which got B positive charge, that will attack, or that will join with either ortho position or para positions. Hence you will get two product. One product you will get at para position, other you will get at ortho position. Means para position, if it will go, then it will form para bromo anisole. Para bromo anisole is a major product, and minor product, that is the ortho bromo anisole. Ortho bromo anisole and para bromo anisole, two product you will get. Then para will be major and ortho will be minor. Okay, very less. That this is actually called bromination. And one more, I told you Br minus B is left out. What will happen to that Br minus? Then here from the benzene ring, from the ortho or para position, there H is there, both places. Then actually this two product you are getting, if two molecules of anisole is there only, then you will get. Then here at para position H, that will come out as H plus, that will go to the Br minus, and it will form HBr, hydrogen bromide. Then I have told you about the, I can say, halogenation. Now you can see Friedel-Crafts reaction. Friedel-Crafts reaction means in presence of ElCl3, reaction will take place in presence of AlCl3, anhydrous aluminum chloride. Anisole undergo Friedel-Crafts reaction. What do you mean by the Friedel-Crafts reaction? Then that is the reaction with alkyl and acyl groups. Here in Friedel-Crafts reaction, alkyl and acyl groups are introduced at ortho and para positions by reaction with alkyl halide and acyl halide in the presence of anhydrous aluminum chloride, that is called Lewis acid, and here aluminum AlCl3 will function as catalyst. Then reaction is very simple. This is the ether reaction you are talking about, ether. Then here this one side phenyl group, other side methyl group is there. Then you know that bond will break between O and CH3. Then now suppose this anisole means phenyl group, ether you can tell, one side phenyl group, other side methyl group. This plus methyl chloride CH3Cl in presence of aluminum chloride, and this aluminum chloride must be dissolved in carbon disulfide CH2, and AlCl3 must be anhydrous, no water molecule, anhydrous AlCl3 in CH2 carbon disulfide. Then reaction is very simple, that now that CH3 actually ortho and para position only reaction will take place. Then CH3Cl, when this bond will break, Cn will be negative charge, CH3 will be positive charge. Then suppose it is going on this thing ortho position, then that hydrogen will go as H plus, and Cl from the CH3 is getting negative charge. It will form HCl, correct? And CH3, which is positive charge, that will join with this carbon which is now negatively charged. Hence it will form 2-methyl-toluene, 2-methoxytoluene. Okay, this is the minor product. And what will this means? Ortho position is minor and para position will be major. Means see, now one possibility is that it will go to ortho position. Other possibility is that it will go to para position. Then para position is major product. But now we will ask, why ortho position is minor? Why para position is you can say major? Then here you can understand that in ortho position two groups are close. They are adjacent, very close, and there will be repulsion between the two groups, because oxygen is now having lone pair of electron OCH3, correct, and their CH3 also. Anywhere when two groups are very close, then due to their repulsion, because they have electron, then among electrons repulsion will take place. That's why that will be not desirable, that will be not stronger. They will not like to form that, but possibility is there, it will form. But in para position both groups are far, repulsion will be least or no. That's why that is prefer. Product will be formed will be more. Ortho it will be difficult due to this repulsion. They will form, but not in more quantity. Then this is actually called alkylation. Now you got methyl group is attached. Then this reaction is called Friedel-Crafts, Friedel, Friedel-Crafts alkylation. This is called Friedel-Crafts alkylation. Always remember, this is very, very important reaction. And this reaction takes place in presence of AlCl3 and carbon disulfide. Okay, this must be there, and reaction will be between methyl chloride or RCl, you can tell in general, RCl and anisole means ether. Now I am telling you about for acylation, Friedel-Crafts acylation. Then acylation means what? Now that CH3COCl, that is the acyl group, you know. Acyl, this is acyl, methyl, acyl, what you are telling, but CH3COCl, then CH3CO is acetyl group, okay. Then this CH3COCl is there, then CH3, C double bond O, and Cl is attached with carbon. Then that C and Cl bond will break as usual. Cl will get negative charge, carbon will get positive charge, correct? Then this carbon will join with the either with ortho or para position. Then H will be relieved from either from ortho or para position. If two molecules are there, then only possibility is there that it will form two different products, one at ortho, other with para position. Then now CH3CO Cl, acyl chloride, that will break CO and Cl bond. Cl will get negative, and CH3CO, that C will get positive. Then this positive carbon will join with benzene ring, carbon that having negative charge due to hydrogen gone outside as H plus. Then there it will join. Then now COCH3 bond is introduced in the benzene ring. Then it can join at either at ortho and para. When it joins at ortho position, it is called 2-methoxyacetophenone. 2-methoxyacetophenone. Okay, that is the minor. And when it will join at para position, then it will be called 4-methoxyacetophenone. Both are acetophenone. Why acetophenone? Because CO group is there, C double bond oxygen is there. Acyl group, CH3CO group is there. Then it is forming just like a ketone, ketonic group, CO group. Then in this COCH3 was there, but it attached to benzene. That's why name has been given 2-methoxyacetophenone, acetophenone, or 4-methoxy, if it is para position, 4-methoxyacetophenone. Okay. Now last reaction I am telling you, nitration. Nitration means any ether plus ether, in ether NO2 group you are going to introduce, that is called nitration. Means reaction between ether, that is any sol, here you can tell ether or any sol. Then any sol react with a mixture of concentrated sulfuric acid and nitric acid to yield a mixture of ortho and para nitroanisole. Then you know, for the nitration, concentrated sulfuric acid is required. Okay, and nitric acid, both are required, mixture of both. And that is the concentrated sulfuric acid and nitric acid, both are required. Then purpose you are understanding that actually HNO3 will convert to that H, from HNO3 OH will go. Then what will remain? From HNO3, if OH minus will go, then NO2 will remain, plus NO2 will remain. HNO3, OH is coming as OH minus, then obviously N plus O2 will remain, NO2 will remain, N will have positive charge. Then now same way it will join with carbon of the benzene ring, which is negatively charged due to leaving of H plus. H plus will go, carbon will have negative charge. Then from that carbon, negative carbon, this plus NO2 will join. It is electrophile actually. then it will make a bond. Then it can make bond either at ortho position or at para position, means you will get two product. Then same way para position is ortho position is minor and para position is major, means it will form, if it is joining at carbon number 2, then it will form minor and it will form 2-nitroanisole, 2-nitroanisole, correct. And if it is joining with para position, then it will called 4-nitroanisole. Okay. Then this I have told you. I one more thing. Here OH removed from the HNO3, OH gone, OH minus. What will happen to this OH minus? Then here you see role of H2SO4, concentrated H2SO4. Then here this OH minus and H plus from the benzene ring, that will form water. Then now role of H2SO4, why concentrated, now you can understand. This is a H2SO4 is what? H2SO4 is dehydrating agent. It will absorb the H2O. Then now H2O is formed, OH minus plus H plus. Water is formed, quickly H2SO4 will absorb. It is because it is dehydrating agent. And now that to break the HNO3, to break this, to remove the OH minus from HNO3 and to remove H plus from the benzene ring, this H2SO4 is responsible, because it is there, it is trying to take water molecules. Wherever possibility is there, it will break that bond. Then whatever possibility was there, OH from HNO3 and H plus from benzene, it has broken due to the H2SO4. It made them loose and broken and it taken. Then now I have told you about the nitration. Then now I have this chapter I have finished completely, means ethyl alcohol, phenol and ether chapters finished completely. Next class I will start new chapter. Okay, thank you.